has been mentioned before, and that takes care directly of this very, very, very subtle, very complicated way of deciding if whatever is authorized or not to go to a certain site.
Okay, yeah, that's, sorry. Yeah, we could do. Okay. No, I mean, this is sort of one of the things with speaking at this kind of meeting is that you have it's sort of very PowerPoint centric and thereby Microsoft centric. And I'm not a Microsoft user at all. I'm making a point of it. So I'm not using PowerPoint. So that's why it's HTML, because I thought that at least that Microsoft can handle it too. So that's the reason for having it this way. So, and I think that actually part of the presentation, the fonts will be quite small actually. So maybe Ingrid, you should move up front, or other people also might want to move up front. So is that okay? Yeah. Well, maybe I shouldn't say anything about that specifically. The SPOCP is an abbreviation, or it stands for Simple Policy Control Protocol, or project, or whatever that starts with an P. And as Diego started by saying, it's not so simple, but actually that's sort of the thing you actually end up with sooner or later. Anyway, this is a joint Swedish and Norwegian project. A couple of Swedish universities, the NRNs in Sweden and Norway, are sort of the participants in this project. It started about a year ago, and this specific project, this part of it anyway, will end at the last of May this year. I mean, a couple of days from now. But there will be a continuation, so the project will go on for another year. And the goals we had was, of course, to design such a service, authorization service, but also to build one and to see that we actually make a proof of concept implementation to make certain that it actually worked, what you thought would work. And it's not just necessary to do the authorization server as such. You also have to modify a couple of applications to use this in order to see that it actually works. I mean, are you able to modify applications so they can use it or not, for instance? That's a good question to ask. And of course, there are some applications which you aren't able to modify, like which are commercial, for instance. So in that case, what would you do? And the last point we were aiming for was trying to build an administrative interface. And sad to say, we actually missed out on that one, I could say. So that's what we're going to do next year. That's really the hard part. So, and look, this is sort of just repeating what other presentations already said. Why would we want to do anything like that? Why would we sort of standardize on the middleware components? Of course, if you have sort of standardized middleware components, you only have to learn sort of one of them. And you don't have to learn sort of every access control sort of system that you have for there's a new one for every application that you're using. There's one for SendMail, there is another one for FTP, there's another one for, you name any application. And if you have these, so if you have the possibility of having one access control system for all these applications, you just have to learn one. And that makes it much easier when you're switching personnel, for instance. So the new ones coming in only have to learn one of them. It's easier to integrate with other middleware components if it's sort of built from the beginning to do that. Of course, it also facilitates building new applications when you already have all these functions there. So you don't have to bother about sort of building authentication modules in the new application, authorization or something like that. There is already components which you can use for doing that. Richer functionality. In some aspects, it actually has richer functionality than access control systems that you see in lots of applications. There's the flip side of that, of course, and that's the if you have an access control system which is built together with an application, of course, it can do things that this kind of generalized access control system can't, because it doesn't have access to the same information that the one that's inside the application. Piece of the middleware puzzle. Well, this is sort of the shibboleth path. You have the authentication service, which might be a shibboleth. So, and we sort of the SPOCP comes in when you have provided the resource system with the attributes, for instance. I mean, where the SHAR has given the attributes to the resource, and then it's the time for talking to SPOCP. But SPOCP is also able to contact other information resources, like checking the weather, like checking time, of course. We're also doing a lot of other things. So in fact, the application might not have almost no information, actually in some cases, no information at all about the users that wants to do anything. But everything is actually done by the authorization service checking information in sort of the environment before giving you access or not to the service. So the key features of SPOCP then, it's built around a well-defined rule syntax. We haven't specified any semantics. It's a rule syntax we have defined. Well, we haven't defined it. We have just picked one which was already defined for us. Sort of. And we think that we could, by using this syntax, model almost any type of policies you would like to build. And since we also wanted to build sort of the existing infrastructure, we wanted to allow for the usage of external information resources. So we have something called boundary conditions, and you will see more of that later in the talk or hear about it. And another thing is that we can actually place this authorization server as close to the application as you want it. It comes in different varieties, so you can get it as a library, so you can link it hard to the application, in which case you have a C API, which you can use. You can also have it listening on some IP port, either a Unix domain socket or a internet port somewhere. We have, to be politically correct, also made a SOAP SAML implementation. And I'm saying politically correct because in some cases it might be the proper thing to do, but in other cases, if you care, for instance, about performance, it's not the proper thing to do. Because it actually is a lot slower if you're going to start looking at XML and parsing XML structures before you know what you want to do or get at the information. Another feature we have, and this is might be most interesting if you have it very close to the application, is that we can, apart from just giving back a positive or a negative answer, if we give it back a positive answer, we can also provide information together with that. Something which we call the blob. That's sort of some kind of information. We don't care about the information. It's just a binary thing that we pass back. It could be a certificate. It could be arguments that you need in order to run a function, or something like that. It could be anything. The rule syntax is something which is called S-expression. It comes from Lisp originally, and then there was Ronald Rivest, which I assume is well known in these circles, and someone called Lampson, who actually wrote about this in late 90s, 96, I think, that was the first paper they published around this. And it was used in IETF by a working group called SPOCP, SPKI, which was an attempt to build something which is sort of in between PGP and PKI, X509-based PKI. It was a good attempt, but it never took off, sort of. They made all the specification and so forth, but there is no one who is really using it, as I know it anyway today. Now, there were some guys working at Swedish Institute of Computer Science, and I was working there for some time too, who picked up on this, and there was one guy working on delegation. And we took this S expression and used in this context. And we were working together with the Swedish Army at that time. And they wanted a mathematical formal proof that this policy engine will always provide them with the correct answer, given sort of the input, the policies that were there, and the input they got in the form of information. That this engine will always produce the right answer. Of course, that's very important in military circumstances, but also in other circumstances. And we were able to do that. There is a formal proof that this machine always will provide you with the correct answer. And basically what it's all about is that if you have an S expression, and these are a couple of S expressions, you make it more specific by adding elements. So I assume that most of you know about directories. So this is sort of a representation of a directory name, a distinguished name. And if you add another element, it's more specific. I mean, this is everyone within the Umeå University. These are the persons within that. And this is a specific person. And if you go further, you have, for instance, the attribute definition, and you even get the value. So when you add elements, you get more specific. And what it's all about is that the policy engine, it has rules, and then it gets a query about someone wants to do something. And it compares those. And if the query is more specific than the rule, then the thing is allowed. But if you can't compare them, or if it's more, or if the rule is more specific, sort of, is disallowed. So it's very simple, and that's where the simple in SPOCP comes from. Basic also to this is that everything that is not explicitly permitted is prohibited. And we only have positive rules. You can't say that someone is disallowed to do something. You only can say that someone is allowed to do something. And of course, if you doesn't say that anyone is allowed to do something, then of course everyone is disallowed. But you only can sort of add positive rules. And one of the reasons for that came actually out of the doing the mathematical proof. Because when you ended up in the situation that you have negative and positive rules, you couldn't really say. It wasn't possible to prove that you will always provide the correct answer. Another thing is there is no order between rules. So the thing is that it compares the question against the set of rules, and if some rule is allowing it, then it's allowed.
Are you taking questions now or later?
I'm.
So the question in here would be, if we have a university that's hierarchically structured, as in your distinguished names, but we wanted to allow everybody from the university but exclude the biology department, how would we do that?
That's sort of the flip side of the thing. So you actually have to define sort of something which is valid for this set of departments, which is not the biology department.
So you have to explicitly enumerate?
Yes. There's a question back there.
I had actually more or less the same question. It goes even further than that. What if some bad person does bad things?
Like-
how are you going to disallow him on the system, for instance?
What do we mean by doing bad things, like adding rules which shouldn't be there?
No, sorry. You have some resources you protect.
Yeah.
The whole university is allowed to get to the Blackboard learning system. But one person has been doing bad things.
Right. There is one option you can use, and that's what I mentioned initially. It's what we call the boundary conditions, which actually allows you to, in the rules, specify that the persons who are allowed to do this shouldn't appear in this file, for instance. In which case, you can in the file sort of put up all the persons who shouldn't be allowed to do anything. So that's one possibility. So there are ways around this. I mean, I don't want to go into the deep technical stuff here, but there are ways around that. But I agree that this is actually a problem. We couldn't get away from it, since we wanted to be sort of have the mathematical proof for it. So there's no way around that. And this I already have said. Boundary conditions. Well, you can use them then to extend the policy so that you can sort of express in a pure S expression to include information from other information resources. And we also have the possibility to use a simple variable substitution so that you can sort of provide variables with the query, which then can be used sort of when you test the boundary condition. And what we have done when it comes to boundary conditions is, of course, to have one for time. So you can check this is allowed only between 3 and 5 on Fridays, or this is allowed only if it's a normal working day, not on holidays. We also have boundary conditions where you can connect to a GDBM file. It's sort of a simple database type. To LDAP, of course, you can do lots of LDAP queries through this. We have a specific sort of format for that. We're not using LDAP's filters as such. We have a specific format for doing that. The last two, last login and RBL, is something we have found useful when it comes to using SPOCP in SendMail or any other kind of SMTP server. But I'll come back to that later too. There is a couple of other boundary conditions too. So what does it take then to sort of SPOCP-fy an application? Well, of course, you have to find out where in the application, when in sort of the actions that the application takes, that is appropriate to put in a sort of checkpoint. Is this user allowed to go further than this? The other thing is that those checkpoints, you have to know what kind of information does the application have. So what can I sort of make my checks on? And another thing is that you ought to know what kind of external information resources you have. Like if you have an enterprise directory, or if you have other types of information that you would like to use in this context. So if you look at an SMT, when it comes to SMT policies, for instance, SMTP server, these are sort of the stages that an SMTP server goes through when it comes to taking in a message and sending it forth. And it's, of course, first the SMTP connection as such. Then you might have SMTP authentication between the servers. Then you have sort of the mail from, where is this mail from? And then you have the receipt to. And that's it. After that, you have the data. Someone is sending the data. But you should take the decision before you're doing that. Because if you take the decision after you have accepted the data, even if you say, I don't want this mail, There are some mail service out there who doesn't sort of take that as an answer. They will try to resend the same mail over and over again. So you have to take the decision before the data part. So at the SMTP connection, what do you know? Well, you know the IP address. How bad it ever is, that's the only thing you know. And you possibly know the domain name if you have a DNS somewhere in the vicinity, and if you trust the DNS. So a query in this case would look something like that, like this. You have the resource is SMTP then. This is, by the way, this is sort of a convention we have used when it comes to building these S expressions. That you split it up into resource, action, and subject. It's not necessary to do that. You can split it up any sort of way you want to do it. But it's, we have found that lots of people want to think in that sort of those terms. So in this case, you have the resource, which is SMTP. You have the action, which is sort of a connection. And you have the subject, which is the host on the other end. You have an IP number, and you might have the domain name. And in this case, you might have rules that then say that, okay, when it comes to connection, I only allow connections from hosts who had IP addresses within this space. And you have a range of IP addresses defined there. Or I can use the RBL, which is the real-time black hole list, which is managed by people in the US. And you can say, if this host is on the real-time black hole list, I don't want to talk to it. Doesn't matter what it is. On the other hand, you can actually define which sort of the real-time body list, I mean, those you want to talk to. You can put in your own DNS and say, okay, I allow these guys. And then you can do a check from that. Or I can say that it doesn't matter which IP number you have. If you come from this domain, it's okay. So these are the type of rules you can put up then at this stage. The next stage then, you know the mail address of the sender. And of course, you can combine then the information you have about the host who is trying to send you the email and the information about the sender. So in this case, the query then would be sort of again, the resource SMTP, and the action in this case, mail. And then you have the subject is a combination then between the IP numbers of the host and who the mail is from. And the rules, again, might be that you don't care about the IP number or host or something like that. As long as it's from the mail address, the domain part of the mail address is within a specific domain, you allow them to send to you, disregarding of the recipient or something like that. Or you might have a boundary condition. This is, I guess, very hard for you to see in the back. No problem. Good. Hawkeye. Right. Yes, hope. Anyway, it's a LDAP. Anyway, this is a LDAP boundary condition, and if I walk through this, it says that you have to talk to a LDAP host, which is ldap.umu.se, and in the subtree persons, cn equals persons, dc equals umu, dc equals se, it should look for anyone who has that mail address that was provided here in the query. If there is someone who has that mail address, it's someone who I should serve, in which case I allow that mail sort of to appear. Yeah, that's another boundary. I don't take up that. And the third one is recip2. where you also have sort of where the mail should go. In which case you can say that only allow mail from, in this case, my own domain, Catalogix, if the mail is going to persons at the computer science department at Umeå University. And other such things. These are two LDAP boundary conditions again. Switch to web then. Access control, if you're looking at web servers. The first thing, well, there's only one options when it comes to a sort of a point where you have to make the decision whether you should allow access or not to the resource. So that's not an option. That's not something you have to sort of look for. But at that point, you might have different types of information depending on what kind of connection you have. You have, of course, the normal HTTP connection, in which case you only have the IP number of the sort of web client. You might use HTTPS, in which case you also know the SSL version, but you still doesn't know any more about the client. You might use authentication, in which case you have a user ID, and you also have authentication name and authentication types, is something that comes out of the HTTP conf file, configuration file. And of course you add things, and if you also have client certificate, if you demand client certificates, you also have subject distinguished name from the certificate that you get from the client, and issuer distinguished name. So these are the kind of this is the information you have available, depending on the connection at the point of access. So the simple then, when you have only a HTTP connection and you get the query, someone wants to read the index HTML file. In this case, you have the resource is index HTML. The action is, in this case, 0, because that's how it's represented the HTTP server. Get is 0, post is, I get thing 2, put is 1, and so forth. And you get the information about who is connecting. And in the HTTP conf file, you only have one line. And HT access files you can sort of get rid of. You don't need them anymore. Oh, good. Okay. So in the conf file, you only specify which SPOCP server you should talk to. And you can also have the possibility of specifying sort of the SPOCP domain, so you don't only have sort of the domain of the web server, but also a SPOCP domain. This allows you to do some neat stuff. This is hardly readable, but you can look at it on the net. Anyway, so I just got sort of the message that it's nearing the end. So this is what we have learned so far from sort of trying to do this, is that we haven't found any policies that we haven't been able to express in S expressions. So obviously the choice of S expression as the rule syntax wasn't that bad. It seems fast enough. There have been some tests about the performance, and we haven't seen sort of any problems when it comes to performance. And of course that depends on what kind of applications you're testing. We have tested applications where humans are involved. We haven't tested applications where you just have networks components involved, in which case this probably wouldn't perform fast enough. Of course, we have found out that technology is just part of the game. It's definitely sort of not the end of it. It's not easy to define policies, and this is where the hard part comes in, which Diego had found out when he had sort of tried to use SPOCP together with PAPI. And the two maybe most interesting things, when the number of policies increases and it managed in a decentralized way, I haven't told you this, but actually SPOCP allows you to delegate who is allowed to sort of add new rules. And you can delegate in several steps. But if you do that, there you have problems sort of finding out the coverage of all the rules. Are there some who is overlapping? And well, since we don't have negative rules, sort of no one can take away something which you have given someone. But there is when it comes to the user interface, this is a big problem of sort of drawing for them a picture of what rules are apply in this in this case. So that's really the hard part. And the last thing is that we really need tools for post-mortem analysis. Like, I didn't get access to these things. Why? It might be because if we're using boundary condition, because there was one attribute in a directory somewhere who wasn't spelled correctly, or the time limits wasn't placed correctly, or something which you don't have control over. And you really have to find out why. And those tools we don't have today, but we have to find them, or build them rather, sooner or later. And as maybe I should finish soon, but yeah, he's nodding. I just wanted to say that the applications we have been working with so far is that we have made Apache control modules, access control modules, of course, as you have seen already. The SMTP server we have been working with is XIM, which is the English one made in Cambridge. And a very good one, I would say, also. And we have written a PAM module. PAM is basically for authentication, but actually there is an instance where it is about authorization, so we added it there. We have modified Open LDAP to not use its own access control system, but use SPOCP instead. And I'm going to rewrite that. It turned out it worked, but there were some sort of funny things about it. So I'm going to rewrite that. And PAPI has been rewritten to use SPOCP. Was there any more? Have I forgotten any? I don't think so. And that's it. David.
How does the decision engine know that it's got the correct policy and not a masquerading policy, and B, the full policy?
All the policy is stored in the policy engine. The policy engine doesn't collect policies from other places. It has everything local. So it knows about that. Now, the other question is, of course, all the attributes you get, how do you trust those? And that's sort of the same problem that lots of other. You have to trust someone, otherwise it doesn't work. So.
Where are they stored, the attributes?
No, well, the attributes, either you get the attribute, through the connection from the policy enforcer, because this is the policy decision point. And in that case, you have to believe the policy enforcer. Or you collect the information from somewhere else. And in that case, you have to, of course, believe in that information provider, like an LDAP server or a time. So,
but how is the decision engine configured to say who to believe?
Yeah. There is the possibility, depending on what protocol you're using. I mean, if you're linking this policy engine with the application, that's not a problem. If you're using a internet connection, like if you have it on a port somewhere, then of course you can say that you have to use SSL, and you have to use SSL with a client certificate, in which case the application is the client, and it has to provide the certificate which the server believes in. So there are options which you can use. In some cases you want to use it. In some cases you have very local networks, so it doesn't really isn't an issue in some cases.
You mentioned that you need tools for post-mortem analysis, and you were specifically talking about the violation of boundary conditions. My simple question is, you said with the yes from SPOCP, you can also send a blob.
Mm-hmm.
Do you also send a blob with a no answer?
No.
So if your mail server, for instance, doesn't allow you, it doesn't say, for instance, this email address is not present in the LDAP directory.
Right. No. It's a matter of, well, there are two problems with that. Firstly, it might not be so simple that it's only one rule who is applicable, in which case you have to sort of send back 20 different reasons for this. It's not sort of, you shouldn't be allowed to do this. And that doesn't scale. I mean, you can't do that. The other thing is that you don't want to provide, and this again comes from the military side, where you don't provide any information about the rules to the querier. They shouldn't know about the policies, because in that case they could sort of use that information. So you never should give it out. Ken, you had a question. Okay.
Did you mention the traditional applications we are using it with? The NIA?
Oh, sorry. No, I didn't. No. Okay. Sorry. There are two new systems, and I think Torben actually mentioned one of them in his presentation, who is dealing with students and managing students, sort of. And both of these are using SPOCP as their authorization system.
I'm curious about this performance issue with SAML, because we watched Michael do the demo, and I didn't fall asleep during any of the queries, despite lots of network lag. So I must be missing something. Is it something about the volume, the number of interactions? Because
let's bring up the OpenLDAP then. OpenLDAP, if you make a query to OpenLDAP, and you make a search, and you get back 100 entries, and each of these entries contains 10 attributes, say, with attributes values. The number of questions to authorization system is then 100 times 10. So you will get 1,000 questions to the authorization system for one query to the LDAP server. So there you have performance issue. So there are some applications where it doesn't really matter, like if you do a web sort of query, like you want to see a page, because you expect it to take some time because you never know about the network and so forth. But in the other cases, it really matters.
is that wisdom set down somewhere? Because I think that's really useful in terms of precisely what the issues with SAML use is, because there's a lot of Kool-Aid out there that should be informed.
No, I haven't written it down.
Just to mention, apart from the...
Use just one mic.
Yeah. No, it was not sounding. So
Okay.
So, don't worry, it's the same. So apart from that, I remember a presentation in a conference last year in which people were talking about a model for a pay-per-view download on mobile devices, in which this kind of SAML interrogation will be also very expensive because of the capabilities of the receiving systems. So it's well, if you don't have any more comments or questions, I would like to thank you all for attending the session.